My name's Nancy Chabot. I'm a planetary scientist here at APL in the space exploration sector. And I'm really pleased to be here today to talk to you about the DART mission on behalf of the large DART team. DART is the Double Asteroid Redirection Test. It's going to be the first mission to demonstrate asteroid deflection with kinetic impactor technology. So the spacecraft is going to impact the asteroid, and that's going to deflect it, sort of changing its position and its future path. This is the sort of technology that you would use if an asteroid was potentially on a collision course with the Earth and you wanted to deflect it to keep that from happening. APL is leading this mission, building this mission for NASA. We have a number of partners who are also contributing, shown down along the bottom of that slide there. To go into a few more details about the mission overview and what the mission is about and when it happens, the launch window opens in July of 2021, and the impact would happen in September of 2022. Now, the target for the DART mission is the Didymos asteroid system, named Didymos. And it's important to state up front that Didymos is not a threat to the Earth. So this is not a threat to the Earth. This asteroid is not on a collision course with the Earth. This is a good way to do this first test to demonstrate this technology. And Didymos is actually two asteroids, a binary asteroid system, or a double asteroid system, if you will, hence the name of the mission, Double Asteroid Redirection Test. And the DART target is the smaller of the two asteroids. So there's a large asteroid called Didymos A, 780 meters in diameter. And then there's a smaller asteroid, this 160-meter Didymos B, that goes around the main asteroid every 12 hours. And so the DART spacecraft is going to come speeding in at over 6 kilometers per second. A few days ahead of time, there's a CubeSat that gets kicked off. It's contributed by the Italian Space Agency. It's named LiCiACube, and it'll take a few images of the impact. But the DART spacecraft will impact Didymos B, and it will deflect it. It will change its path around the larger asteroid. So this is a very safe and effective way to do this first test of deflecting, changing the path of an asteroid. But the critical measurements are not going to be made by the spacecraft itself. It's actually going to be made from Earth-based telescopes. And so the Earth-based telescopes are going to be able to see how much we've changed its path. Currently, it's going at about 12 hours. It goes around the main asteroid. We think we're going to change this path by about 10 minutes, but figuring out that exact number is what the DART mission is going to do. So the goals of DART are very simple or straightforward. It's to target this binary asteroid system, to cause a change to the orbital period of Didymos B going around Didymos A, and then to measure that from the Earth-based telescopes. But at this point, I kind of like to take a step back and address the question about, do we really need something like DART? And to start that discussion, I like to show this little video. So this is about the Chelyabinsk event that happened in 2013. So there's this fireball exploded over Russia in 2013. Here you see Chelyabinsk, Russia, coming into view. It's a city in Russia with a population of over 1 million people. And without any warning, in February of 2013, a meteor came towards this city and exploded in the skies over this city. And the shockwave released 20 to 30 times more energy than a World War II atomic bomb. Spectacular images of this fireball streaking across the sky, captured by dash cam videos in this city from number of places. Shattered windows across 6 cities, has hospitalized hundreds of people. And so you can see that this is, one example of these objects hitting the Earth. Chelyabinsk is not really that unique, though. So this is a map of small asteroids that have hit the Earth for roughly the last 30 years. And Chelyabinsk is the largest one that's happened in that amount of time. And you can see it here on this map as that red dot in Russia. But you'll also see there's a lot of other dots on this map. This is not necessarily a unique event. Things are hitting the Earth all of the time. Now, Chelyabinsk is, before it hit the Earth, is estimated to have been about 20 meters in size. And a lot of times when people think about asteroid impacts, they think about the one that killed the dinosaurs, right? And so this is a very different scale of object that we're talking about. So down on the bottom right corner is some text about this dinosaur killer asteroid. And it was 10 to 15 kilometers in size. And I'm happy to say that we are tracking all those asteroids. NASA is tracking all of those asteroids. And there are none of that size that are on a collision course with the Earth. So we're safe from these extinction-level dinosaur-killing events. But there's a lot of space between the Chelyabinsk size of 20 meters and these dinosaur killers of 10 kilometers, these few hundred meters objects. And in fact, one of these fell in Tunguska, Russia in 1908. And it was estimated to be between 60 to 190 meters in size. So there's sort of a few hundred meters, and it leveled forests as if they were just matchsticks blown over when this occurred. And this sort of event happens every few centuries. And so it's sort of these hundreds of meters diameter objects that we're really concerned about. And this population, we actually think we've only discovered a third of the objects this size that are out there. And so there's actually 2/3 of this asteroid population that we're not sure where they are. What would something like this do if it actually hit the Earth? Well, Barringer Crater, meteor crater in Arizona is a nice example. Maybe some of you have been there. They have a great visitor center. It's a beautifully preferred impact crater just outside, like near the Grand Canyon sort of area. And you can see that impact crater there. So this is believed to have formed from about a 50-meter asteroid that was made out of metal. So very, very dense asteroid, lots of energy. 50,000 years ago, hit into this region of Arizona. And it made a crater, which is really nice. It's about 1 kilometer in diameter, a few hundred meters deep. But the devastation caused from an event like this is much bigger than just the crater that you see today. And that's shown from this model of what the devastation would have been over on the right side. The fireball extending out to 10 kilometers. Large animals killed or wounded to 24 kilometers. Hurricane force winds out to 40 kilometers. And then you can take this same map and overlay it on DC. And you can just get a scale of what a devastating natural disaster event this would be, particularly in a heavily populated area. Consequently, because of this potential threat from the asteroids that are out there, there was a National Academies study that was commissioned. It's called Defending Planet Earth. So that was in 2010. And they looked at this threat and they said, what is the main things that we should do? And their recommendation for the highest priority mission to do is to do this kinetic impactor technology demonstration, exactly what DART is doing. And this graphic from that report sort of illustrates that. The y-axis is the size, and we've been talking a lot about the size, but the x-axis is equally important, and that's the warning time that you have to deal with this threat. Because the idea with all of this is definitely not to disrupt it, but to deflect it. So you're not trying to disrupt this object, you're trying to give it a small nudge and have lots of time for this small nudge to add up to a grander change of its path, avoiding a future collision with the Earth. If you have a large object, which is the top of that graphic, you need to give it a pretty big nudge, even just to make a little bit of change in its position. But these are the dinosaur killers. These are the ones that are not really the threat that we're concerned about. It's this few hundred meters range of population where we think that there's about 5,000 potentially hazardous asteroids of sort of this 100-meter size, these PHAs on the graph there. And that's where kinetic impactor technology was judged to be the most mature in technology that you might want to do if one of these things was on a collision course with the Earth. And DART, you can see, is very well situated on this graph, sort of shown as that dotted blue line going across there. This 160-meter object that we're targeting is right where you want to test this kinetic impactor technology. What's 160 meters? I like to show this little fun graphic just to sort of like bring everybody into size, because sometimes you talk about these scales and they don't really mean very much. So 160 meters is, diameter is bigger than the Statue of Liberty, smaller than the Eiffel Tower. It's kind of the size of a Great Pyramid or maybe a sports stadium or something like that. So you can kind of think about the Great Pyramids hurling towards the Earth. It's not a giant object. The main Didymos A that we're not going to impact is much, much larger, but it's still sort of a considerable amount of mass and size. And Didymos really is the ideal target, and not just because it's the right size that I've been talking a lot about, but because of this double asteroid system. Because we're going to change the path not around the sun, but around this other asteroid. So the DART spacecraft comes in at over 15,000 miles per hour, and it's going to try to hit Didymos B nearly head on. And you can see the original orbit of Didymos B in the white line. And when you hit it nearly head on, you're going to change its orbit to sort of that blue line, about 1% change in its orbit. The blue line's a little exaggerated, but you get the idea. Hitting this thing head on, causing a deflection of this asteroid around the main one. It's a careful, well thought out test. But what's really important about this double asteroid test and being able to do it this way is that this spacecraft is going to be totally destroyed. It's not going to be able to measure how much of a deflection it made when this happens. Instead, we're going to use existing telescopes here on the Earth in order to make that crucial measurement. So it's a very cost-effective way in order to do this focused first test of the demonstration. And that's actually why the choice for the impact date is in September of 2022, because that's when the distance between Earth and the Didymos asteroid system is minimized. So you can get the highest quality data from your existing Earth-based telescopes in order to make this crucial measurement. It's very ingenious, actually, of doing this focused mission in order to demonstrate this technology for the first time. So there's a few other key technologies that I wanted to just mention briefly on DART, along with this overall kinetic impactor technology. And one of the most important ones is the autonomous SmartNav system. And so we're targeting the smaller asteroid, but you won't actually be able to tell the difference between the smaller asteroid and the larger asteroid until the last hour of the mission. And so all of this has to be done on board. to pick out this smaller asteroid in order to try to impact it into the center in order to make this deflection. And so that builds on a lot of APL decades of missile guidance, algorithm development, and experience in order to do that. There's only one payload on here. It's a camera named Draco. And Draco is modified from LORRI, which was on the New Horizons mission, took amazing pictures of Pluto. So we're using that technology. It's also going to be the first flight of NASA's Next-C ion propulsion engine, which is going to be more powerful than anything NASA's flown before. It's also using these rollout solar arrays, which are going to be deployed in space and roll out. And when they're deployed, they're going to be 19 meters from tip to tip. So a pretty sizable spacecraft there. But DART is just one part of NASA's overall planetary defense strategy. You would never just do DART in isolation. Equally important is to assess what's out there, to keep track of those things, to search, detect, and track, find these new objects that we have yet to discover in our population, characterize these objects so you know what you're dealing with, and if you did have to deal with them. Plan, coordinate. This is an international effort, and these are international working groups to deal with these issues. And finally, there's mitigate. And that's where DART comes in. If there is a threat and you need to do something about it, let's be ready. Let's do this technology demonstration now. So you would think that this makes a lot of sense, but actually this effort's been growing considerably. NASA's Planetary Defense Coordination Office, which leads this effort, was only established in 2016. And so before there was a few activities going on, but they weren't very well coordinated. So since then, NASA has taken a much more concerted approach, and DART is the first spacecraft mission that's being flown by NASA's Planetary Defense Coordination Office, hence NASA's first planetary defense mission. So along with this Planetary Defense Coordination Office getting set up for NASA, there's been really increased visibility for planetary defense at the top levels of NASA. So this is the NASA administrator attending the International Academy of Astronomics Planetary Defense Conference held just down the road here a few months ago. And stressing, he did the opening address, which was also broadcast on the web, and so worldwide people were watching this, stressing the fundamental importance of planetary defense efforts to our planet. And at this conference, it was much more than just NASA. This really is an international effort. There were more than 250 attendees from 20 plus countries. And DART was very well represented. We had a number of presentations that went over well. But one of the unique things about this conference is there's an exercise that's done. So a hypothetical asteroid impact coming towards the Earth. And by day 5, I've shown what the graphic looked like up there. There was a 60-meter object headed towards Manhattan. And it was going to be 1,000 times more powerful than the bomb that was dropped in Hiroshima. And so you can see where this would be a very big natural disaster if it happened, just to reiterate that point. And this conference had not just scientists and engineers, but policymakers, people from FEMA, people from the press talking about how you would communicate these sorts of events. And so planetary defense as a whole, as a topic, is really increasing in the efforts, both within NASA and internationally. So DART is an important demonstration of this kinetic impactor deflection technology, but it's also sort of pioneering the way for these future planetary defense efforts in a field that's really growing right now. I know I feel privileged to be part of the DART team that's working on this to make the first planetary defense mission a reality. Thank you.